Okay, let's look at thermal expansion here a little bit. So we have this bridge built in the summer with a temperature of 35 degrees Celsius. And we're given it's 80 meters when it's constructed. And we want to know what is the length of the bridge on a cold winter day when the temperature is negative 12 degrees, right? So we just want, the length of it, right? So we can use thermal expansion here, right? And we can, say, our final length, right? L final is going to be our starting length plus the change in length, right? So, we know the starting length, L naught was 80 meters. And so all we really need is delta L, which we can use, a thermal expansion equation for here, right? So, actually, I guess let's extract some of this information that we know. So L naught was equal to 80 meters. We know that it's 35 degrees and then it goes to negative 12 degrees, right? So we have a change in temperature. It's going to be final minus initial, negative 12 minus 35, right? So it's going to be 47 degrees cooler, right? So that's negative 47 degrees Celsius, which, by the way, would be the same thing as negative 47 Kelvin, right? So delta T is negative 47 Kelvin, or that's negative 47 degrees Celsius, as long as we're looking for a delta T, right? Not an absolute T, which you would see in like the ideal gas law. Okay, and we also need, what else do we need? If delta L, our equation here, the change in length is the starting length times the coefficient of linear or thermal linear expansion times the change in temperature. We also need alpha, right? So we can go look this up in your book in table 13.2. And we get the coefficient of linear expansion for steel, because it's a steel bridge, so this is important that it's steel, right? This is equal to 12 times 10 to the negative 6th per degree Celsius. Okay? And so, we see our units are going to work out, right? That's just going to be a number divided by degrees Celsius, multiplied by degrees Celsius. We have a number, multiply that by something in meters, and we have delta L is going to be in meters. Okay, now it's just a matter of plugging it in then, right? So we have delta L is 80 meters times 12 times 10 to the negative 6th per degree Celsius times negative 47 degrees Celsius. And we get here that delta L is equal to negative 0.04512 meters. That's not a lot, 4.5 centimeters, right? You don't expect it to go a whole lot, right? That's about 2 inches, almost 2 inches. So one of the things that's important to note here is that, with this delta L, if delta T is negative, then delta L becomes negative as well, right? So as the temperature goes down, it shrinks. And if delta T is positive, then delta L is positive. So as the temperature goes up, it expands. As the temperature goes down, it decreases, which is exactly what we, said would happen when we came up with this equation, right? So it should shrink because it's gotten colder, and we'll just add this on to the original length. And so we have L is going to be equal to 80 plus a negative 0.04512, and so that comes out to 79.95 meters will be the length of it on a cold winter day here. So hopefully the supports are big enough that it's still on its supports after this time, or there was some sort of expansion contraction joint put in there.